This is the physics of dance. We're going to be exploring 3 different elements of dance, particularly ballet. The first are balances, second, pirouettes, which are turns, and third, grand allegro, which is jumps. So the first video that we'll see is of somebody doing balances. Dancers have to do balances in multiple different positions, some harder than others, and we're going to explore what it takes to be able to balance and stay there for a long time.
We see here that she's balancing in a nice passe position because her center of gravity is directly over the area where her foot comes in contact with the floor. She can balance in this position because once again her center of gravity is right above where her foot comes in contact with the floor. Her body is in a completely straight line, as dancers have to adjust their bodies in a straight line.
Perfect.
This time her center of gravity is not above her toes, so she falls over.
Perfect, that's perfect. Next are pirouettes. Perfect. That's perfect. We're going to be calculating the angular momentum of her first pirouette, and the formula that we're going to use for that is angular momentum equals moment of inertia or rotational inertia times the angular velocity. We already know what her angular velocity is down here, which is 1 rotation per second, which means that she did 1 pirouette in 1 second. So that's how many pirouettes that she completed in a second. So we need to find her rotational inertia, however, and how we find that is we multiply her mass times the distance of her leg from her axis, which is the middle, the center of going straight through her body. So, and then that value is squared. We will now calculate her full angular momentum because we have found her rotational inertia by multiplying her mass, which is 47 kilograms, times the length of her leg, which is 0.74 meters, and it has to be squared. So we multiply all this together, also by her angular velocity, which is 1 rotation per second because she spun once in 1 second. And so now we have 34.8 kilogram meters squared times 1 rotation per second, which becomes 34.8 kilogram meters per second, which is the same thing as 34.8 Newton meter seconds. The last section of video that will show of dancers is them doing grand allegro across the floor, which is series of jumps and leaps, and dancers seem to float in midair for a second and defy gravity. It's kind of a cool thing to watch, but one of the principles that my teacher uses to help us understand jumping or pushing off of the floor is Newton's third law, which is for every action there is an equal and opposite reaction. So when you push off the floor, you're exerting a force on the floor that pushes you off, and it in turn pushes up on you as well. So enjoy the rest of the video, and thank you for watching the physics of dance. Bye!